hear me.
Microphone answer.
Never mind. Awesome. Okay. So, one, repeat. TLDR, they give you the question, make sure you say it in your own words, because if you misunderstood anything, they'll catch it for you. They're not gonna let you say something wrong and be like, sure, keep going. They'll be like, actually, it's gonna take an array and an integer, it'll never take a string. 2, examples. Typically, they'll provide you with 1. Ask for more. Ask for clarification. So for instance, if it's a function that's gonna take an array and an integer, hint, hint, that might be what our function is taking that we're gonna work with. Ask questions like, what if it takes an empty array? Can the integer be negative? What would that solution look like? Can you give me a couple examples to work with as I'm building my code and then to test at the end? 3, approach. Show of hands, how many of you guys actively pseudocode? Okay, hands down. Show of hands, and be honest, no judgment here. How many of you guys don't know what pseudocoding is? Oh, thank you, instructors of Dumbo. So, especially in whiteboarding, actively pseudocode. Write the stuff in English first, because sometimes you're gonna get problems that are pretty complex. And so if you've written it in English, you can go through and be like, great, I'm gonna translate this line to code. This one, I'm just gonna say I have a function that does that. That is kosher in interviews. One of my first interviews, somebody told me, write Boggle. Do you guys know that game? Mm-hmm. Boggle is a game where there's like an array of letters, like 4x4 or 6x6 grid. It's like, find all the words you possibly can from tiles that are touching. Yeah, that face. And that was my face. Luckily, that interviewer saw my face and was like, it's okay. Like, you can assume that you have some functions that are already written for you. Build out your code, and then we can build out those functions. Let's do this step by step. That interviewer saved me. But the thing that helped me was going through and being like, I'm just gonna say I have a function that checks a word's validity. I'm not gonna write it yet. So when I actually went to write my code, I had all that in plain English, and it made it way easier to make sure I wrote it correctly. What y'all think the next one is? C. If I have my approach, now I'm a code. Yeah. So that's what we're gonna have fun then. All right, and then last, T, what do we think T is? Testing, yeah. So remember those examples we came up with? Actually run your code back through it, make sure it works. They like to see that start to finish. You're not just like, crush that and walk away. You're gonna actually be like, cool, let me make sure all of my edge cases that this actually worked. And if it doesn't, being open-minded and willing to be like, all right, this is where this failed, let me go solve it. Keep that open mind. And then finally, optimize. And that's where I'm gonna go a little bit solo so we can dive into Big O notation. But go back and optimize your code. It's pretty often for somebody to be like, nice solution, but what's its time complexity? I don't expect you to be an expert in Big O by the end of this, by any means. But I wanna give you the tools that if somebody asks that, to be able to break it down line by line, be like, well, this is linear and this is constant, so it ends up just being O of n. Linear time, it's not the best necessarily, but it's solid. To be able to say that confidently, or to be like, oh man, that's quadratic, I could really do better. Even if in an interview situation, you're like, my solution is not optimal and I know that, and I'm not entirely sure how to optimize it, you can say that to an interviewer. Very, very much so. No one is wanting you to fail. They want you to succeed. So if you come at them and you're like, you know what, I know it's not optimal, I know it's actually pretty bad in terms of time complexity because A, B, C, D, and E, but I'm not quite sure where to start to optimize, most interviewers will try to guide you a little bit and then see how you implement it. All right, so my volunteers, are you ready? I'm gonna show us a sample problem, then we're just gonna do it. Okay. In case y'all couldn't tell, I'm like a lot of energy, so if I ever need to bring it down, just let me know. All right. Oh man, okay. This is, yeah, how far we'll go. So, briefly, I'll be the interviewer and then I'm gonna be an interviewee with you guys. All right, write a function called hasTargetSum. It receives 2 arguments, an integer of arrays, an array of integers, and a target integer, such as this. So hasTargetSum, -1, 3, 8, 12, 4, 11, 7, are all in your array, and 10 is the integer, we should get back an array of -1 and 11 and 3 and 7. So nested arrays. So I've already given you one example. So, I'm gonna say your name wrong. Rob? Come on, please. Yeah, I'm gonna make you guys get it. Because also like movement, it's a sunny day, got a lot of energy now. Even though like ours is probably gonna be pretty short. So, if you had to put this in your own words, how would you do it? Own words.
So you would like me to write a function that takes in an array and an integer and returns other arrays that where the numbers inside the arrays sum up to the given integer.
Accurate. Yes, that is correct. Do you have any initial clarification questions you want to ask here?
I guess I was trying to like see the fun thing.
I'll stop being a bother.
So I guess there will be negative numbers. Is there like a restriction on the length of the array?
No, it can be of any length.
Yeah, I can't think of any other
Cool. Some additional ones that I might do, but I also like get like super detail oriented to the point of maybe being annoying in interviews. I'm not gonna lie. Do you have some clarification questions? Oh. Slopes? No decimals. No decimals. All full numbers. That's a really good one. I didn't even think of that one initially. Any other clarification questions that other people have thought of?
Any length does that refer to the length of the arrays within the array?
Your array argument to the function.
Oh, like he needs like if more than 3 integer, more than 3 of the numbers will add up to 10.
Oh,
Oh.
is it just 2 numbers that have to sum up, or more than 2 numbers? It has to be 2 numbers. That's also a really good question.
Can the array be empty?
Yes, the array can be empty.
Oh.
Any additional ones? We've been pretty thorough.
Can the number be 0?
The target integer or in the array of integers?
Target.
Yes. 0 is also fair game.
Negative numbers?
Fair game. Alright, I think we did it. Can you give it up for our volunteers? Alright. I know you're sitting right here, but you're still gonna have to get up. Woo! Alright. Mohammed, what kind of examples would you like to see?
Initial array would be 3, 5, and 10, and 11.
What's our target? You could also use that as a basis. Like, we just clarified a lot of things. Like, 0 is fair game, negative is fair game, empty array is fair game.
-1.
That would turn out to be, that's gonna be that. None of those numbers will add up to -1. How about, I can't close yet. And I don't know, 13, doesn't really matter. We'll still just give you, will not break, we'll just give you an empty array. When you're going through examples, you can do it many ways. You can either create some examples yourself and just be like, just to confirm, that is what that should return, right? Or you can say, can you give me an example with negative numbers, an example with empty arrays, an example with blank, blank, and blank. you like to see any other examples? No, you're good? All right, I'm gonna keep you up here. Well, are there any other examples folks would like to see?
Another question is, what language are we writing in?
Oh, that is a great question. JavaScript. So as a heads up, a good number of places won't let you do your code challenges in Ruby. Ruby's just really, really nice. But because of that, also can make things kind of really easy. So some places will tell you no for Ruby. So I would be prepared to do JavaScript. If you have background in other languages, oftentimes they will say, like, if you want to do it in JavaScript or Python or C, if any of y'all are working in C, they'll give you that option, but typically within their stack. Good question. These markers are not my friend. Any other examples folks want to see? No, it's not. Okay, I want to. Actually, we have one that has a negative number. Never mind. Thank you, Mohammed. Alright, Sadia, it's you girl. It's you girl standing up. It does involve standing up. I know, I did mention that part, so I was like, that's gonna turn some people off, and I want you on. Okay, here's where we're gonna go. What I will do is grab this and put it over here. Cool. So there are our notes. And I just want to pseudocode out. How are we doing this, Sadia? What do you think?
We gotta find a way to go through each of the numbers in the first array. Maybe like take the first index and then add it to each one until we get that triple equals to the target.
So I want to make sure I'm following you right. Can you take a photo of that for me?
Sure.
I left my phone outside. I'm gonna post photos of all the whiteboard stuff
Oh,
because
we're not.
I know this is how I
First.
No! Nah, I can also write this up, that's fine. Success? Good enough. Yeah, yeah, good enough. Thank you. Aw, seriously? It'll be close enough for this to be less in the way. Okay, so Sadia, I wanna make sure that I'm understanding you right. So you wanna loop through the numbers once, and then,
Or like, okay, so I'm thinking of this like the way that we like do even and odd. Like
okay,
how so we have the first one and then we check like the first one plus the second one. And
Or-
then if that doesn't equal that, then okay, it doesn't go into the array. And then the first one plus the third one, the third index, so then we can do that. And then
you go all the way down.
all the way down, and then we would start in the second, so that would be index 1 now, and then all the way down, and then index 2.
So like loop through the numbers in the array,
Yeah.
starting with checking the first one, loop through the rest of the numbers, check the sum, and if it's our target sum, what should we do with it?
We should add it to an array.
All right, so we gotta create an array.
It's gonna give,
Create an array to hold answers, add the pair to our answer array. And then are we done?
no, because it can't stop, it has to go through, like, for all of them,
Mm-hmm.
and then you have to return the answer.
And then we gotta return the answer at the end. The answer array at the end.
I don't know how we incorporate, like,
How we incorporate the
yeah, like,
clarifications we gave?
Yeah, I don't know if it would create, like, it would break if we tried to do negative numbers or something like that, like with the logic that I have right now.
That's a good thing that even, like, I actually love this, and like mapping this to the actual interview experience, because that would be a fine thing to say at this point. It's like, I'm not exactly sure that this will take care of all the clarifications, but I'm gonna just build it. And I'm gonna test it. Like, I think it'll probably be fine. So this might not catch all of our clarifications, i.e. neg numbers, but we're gonna build it and see what happens. Cool. What's that?
I have another question.
Yeah.
Can the return arrays, like, can there be repeated values from the
I love that. Oh, I meant to get to that question. So at this level, I do not care if you have duplicates. So I don't care if, do it up here. I do not care if you return this or you return mind you, I'm like a pretty lenient interviewer. I'm like, I don't care at first. Let's just see what happens. So I'm supposed to be like, no duplicates. Point blank. The way we write it, we can write it either which way. Realistically, the way we wrote it, but they'll tell you one way or the other. That was actually an excellent follow-up question. Thank you for that, because I missed that. Okay, any other thoughts on our strategy? Questions, concerns? Shoot, because you're coming up next, man. Clarify why you got
I'll
on.
this out as thoroughly as possible. So this is starting with all the combinations of the first element plus any other. Is it checking like the second element plus any other? Does it look like it is yet?
So I might have written this poorly in plain English, and if you guys have a better way to phrase it, let me know. I want to make sure I'm clear. So line 26, that is essentially what I mean. Is like this would be a for loop, a first for loop. This would be a second for loop. And so the first one would be like our number one plus our number two. Number one would go all the way down. Number two would also go all the way down. So we would end up going through. Ooh, I thought of another clarification question. If there was a 5 in here, could I do 5 and 5? So many examples now. Say there were also a 5. Could I include getting rid of these? Can you use a number twice? I'm gonna say for now, I also don't care. I'm being super lenient. In general, most likely, like IRL, no. You can only use these number ones. For now, I'm gonna be a little bit like, let's have a lot of playroom in here. Any other questions or thoughts on this approach?
We wrote out our like thought process. How would we get it twice? I think it would be possible if there's 2 things.
It depends on how we write these loops. Yeah. We'll get into it when we start writing. Shoot.
Can we have like double numbers in the array?
Oh, can you have more than one number? Like, could I have 5 and 5?
Yeah.
Yes. You can also have 5 and 5. Good clarification question. Which also, like, as you're starting to build your approach, if you're like, wait, I have more questions, don't keep them to yourself. That's silly. They've got to know what you're thinking. That's like the main thing in the interview process. It's not just what can you produce, but how do you do it. So you've got to talk. And final thoughts before we pack it up for Saturday? The stuff you much didn't want to? All right. All right, Ben, do you want to drive?
Sure.
I'm down with you typing on my computer. I don't care. And then we can all be your navigator.
Yeah.
Don't sound so excited.
Yeah. Okay. So
Don't go down too far, but I also do have a line that's like, secrets below here, do not proceed. You guys will see the secrets later.
So we're gonna let an array because we're gonna modify it. Answers equal empty array.
Cool.
First one.
First one, done.
All right.
Awesome. Okay.
Then loop through the numbers in the array, starting with checking the first one. So let's just write one just to check its start. Yeah. Starting with the first one first, and then modify that later so it can check all the other combinations.
What kind of loop do you want to write?
4.
Let's do a 4. Yeah, let's do a 4.
Yeah, fun. Pick the hardest one, right? So.
There's a reason we're doing it this way.
Okay, yeah.
Do you want to help with the syntax?
So is this one? Is it like acceptable to use a for each in like doing anything
We're gonna
else
do
right
we're
now?
gonna vanilla old school form. Do you want help with syntax
Going
on
back
that?
to like 2010 or something like that.
Yeah.
4.
Going back to the classic.
I equals start at 0.
Yeah.
Testing.
Colon.
Yes.
I is less than I, right?
That's greater than. Carry the wrong way.
Hmm.
You said less than, but wrote greater than.
Greater than, great, okay. Do less than, perfect.
Awesome.
I plus.
Cool.
Yes.
Can you get a let? I heard a couple people be like let in front of the
Let the I.
Let.
Beautiful. All right.
Okay, cool. So you got that first loop.
Mm-hmm.
Awesome.
All right. Navigators. Okay. All right. So yeah, and here we're gonna check. So the array length we're gonna be doing.
So now we've got the
I
first
plus,
number.
yeah. So we're gonna check 0 or I, and then, or we'll start with 0 and then I, and then iterate through that. So.
Keep moving along. So now
Okay.
we essentially can get to the first number. Now we have to be able to get to the second number.
Mm-hmm.
How are we doing that?
Yeah, so it does one thing. Plus. But then here we're starting with 0, so I might need to start at 1, unless we're checking if we're comparing something to itself, which we don't really want to do, right? We could just avoid doing that.
So we're gonna do this super naively for a little bit. Can I provide an assist?
Yes, assist.
So, I like what you're doing here because you're starting to get that comparison for us. I want to build this to make sure that I can check when I is 0 and I'm looking at the first one, that I can also look at every single other thing inside of the array as well. So I'm going to do another 4. And I'm going to call this one second because that one feels more verbose to me, like more understandable. And do, actually, why am I typing all of this? That's so silly. Second plus plus. Let's comment this out for now. Okay. So now I've got one loop getting me my number, well, the first index of a number. The second loop inside of that allowing me to iterate through every single index inside of the array still, while I'm still looking at I0 or I1, and now I can start doing some checking. Nice.
Okay. So then we can do an if statement?
Yeah.
Check if they're equal to the target?
Now we're ready to do the conditional.
Okay. If R brackets first plus R brackets second equals target.
Target tet.
Target.
tet.
Then
That's
we will
wonderful.
add, create a new mini array of the first and the second, and push it into the answers, or add it to the answers. Yeah.
Yeah.
Okay. Answers dot push. I don't know how efficient push is. It's probably fine.
We're not optimizing yet.
Okay.
Stay on the letter. Come on.
Push. All right. We'll create a new array with so first comma second. No, R first.
Like,
Uh-huh.
yeah, there we go.
There we go. That's much better.
This is
Okay.
the best thing that happens to me now. All they have to do is breathe different, and they're like, boy.
Okay, it's looking a little better. We might not all work, but we want to return that at some point. So return answers.
Where should we return?
Outside of all that
outside
stuff. Wait.
before
Oh
the-
yeah, because this is all happening. No, wait. Option move down.
Yes, the option shortcut. Excellent. Okay, I saw your hand.
Oh, I was just wondering if second should be water or first book.
So.
And start at 1, maybe.
We're gonna do it really naively and leave it at 0 right now, because I want to talk about worst case scenarios. But I like what you're thinking there. I like it. Okay. Do we think this might work? Are we ready to test?
You have to leave that second bracket after second.
Which second bracket on which line? 30?
There's an extra bracket.
No, it's Alex.
It's the enclosing array.
Because these two are enclosing number pair. Okay, let's give it up for Ben. Alex. Alex.
Actually, I'm more comfortable on that side of the.
All right, Alex. What I would like you to do is, so we have one test run set up here.
Okay.
And I have my test array, this test array, and this test target.
Uh-huh.
It's our very first test that I put here.
Right.
I would like you to write me a couple more tests that you would like to see to know that your code is working right, or our code is working right. We are all one being right now. One collective Dumbo Flatiron JavaScript master.
Wait, what was I supposed to do again? Another test?
So make another run for me
Uh-huh.
of has target sum.
Right, uh-huh.
And pass it in a test array and a target so you can check what our code is returning. What kind of things might you want to see? Oh, you know what we could do? Grab your phone. Let's check out those examples we created.
Okay. Okay.
See, it was
Oh, I
meant to
see.
be. You were meant to.
Okay.
You were meant to be the tester for this.
Okay. That's where I can somewhere. It's a good
He's trying to do it from memory. It's bold. Ooh.
Okay. So I don't have to do 3, 5, 10, 11, and another 1. And we're going to do another one. Oh, empty array. Oh. Oh.
I think you're inside of the array.
Yeah, I know. Oh, I think double. Okay.
Cool.
There you go.
Are there any other tests you'd like to see?
Sure. Uh-huh.
Maybe one or two more. And then we're actually just gonna run the code and see what happens. See if you broke stuff. You will likely break stuff in an interview. Pro tip, don't freak out. Because coding is stressful. And if you stress out in the interview, they're gonna be like, if I give this person a task, like they time box it at 2 hours and 6 hours in, they haven't done it, how are they gonna act under that pressure? They're gonna keep it cool, they're gonna bring it to a senior dev. Nice.
Mm-hmm.
Okay. Or are they gonna bug? All right, cool. You ready for this? Okay. So one thing we actually have to do, because the way that I set this up, console.log,
Yep.
all these babies. Bam, bam, bam. Bam, bam, bam. Bam, bam. Ayo. I don't know why I'm like this. Okay, cool. So easiest ones are second and third are giving us empty arrays. Is that what we expected?
-1, yes, correct, because nothing come to it -1 or 13.
Perfect.
Mm-hmm.
And empty array should just give us an empty array. All right.
That's correct, because the answer is set up as an empty array.
Mm-hmm. Okay, let's do this one next because I think it's easiest. So what are we expecting here? From 1, 3, 5, 7, and 8.
It should be 3 and 5, or 5 and 3. 3 and 5.
Mm-hmm. And?
And 1 and 8, 7.
Yep. Or 7 and 1.
7, 1.
And we do. We have all 4 of them. You guys give each other love. All right, very last one. The top one, I'm going up here for it. So this was it. And this was the expectation, though we're also allowing this response.
Uh-huh.
And we got it. Hey. All right, thank you, Alex, for giving you some love. Okay. That was excellent. You guys have now gone through your first mock technical interview. Good times. Essentially, we haven't really quite done the O yet, but we're about to get there. How am I on time? Oh, I'm great. I had no idea how long this was going to take because I haven't done this portion before. Hello. I'm gonna forget that every single. We don't have mics in FiDi. It's so fancy. Okay, so now we're gonna optimize. Before we actually do the optimization, just wanna like have a convo around some fundamental concepts that we need in order to optimize, and just like gut check where we're all at. All right, so what is an algorithm? Like how I'm not answering. That's for you. What's an algorithm? What are words that come to mind when I say algorithm? Who?
It's a specific set of steps that yield the same result every time that you execute.
Set of steps, wow, I can't type, that yield the same result. I particularly like the set of steps. Anything anybody wants to add on to that?
Logical thinking.
Logical.
Like logical approach.
An algorithm is a series of steps we take to get from some starting point to some ending point. It can be in code, it can also be in life. Showering is an algorithm. You get in the shower, you lather, you rinse, potentially you repeat if you've been hiking or whatnot and really need to get that together. Making dinner. For me, it typically means cleaning out the dishes that are already in the sink first, but that might not be a part of your algorithm. Algorithms are everywhere. Okay. How do we measure time? It's not a trick question. Yes, and clocks tell us things like hours, minutes, seconds, etc. When we're talking about the efficiency of our code, I moved around too much. When we're talking about the efficiency of our code, do we think we use those same metrics? Numbers, minutes, hours, seconds, etc. RE computers, maybe, but milliseconds. Nowadays, potentially, we have computers in our pockets. Like most of us have more than one computer on us at any given time. Back in the day, computers filled up these rooms. I mean, they still do, but like every computer had to fill up a room. So things were less efficient then. So potentially, other thoughts? Especially if you have not spoken. Be right. So we got some pretty good participation. So, question, thought problem. Do we think an algorithm is going to take the same amount of time on my phone versus my computer versus my grandma's really old computer that she hasn't gotten rid of that was made in like 1998? It's not going to take the same literal amount of time. So when we're talking about computers, instead of time, i.e. minutes, seconds, etc., we want to talk more about the number of computations that are going to happen. How long the actual computer will take, minutes, seconds, hours, to make those computations, that's going to change based upon what machine we're working on. But we can figure out, regardless of machine, how many computations is this going to take? No, too many notes. All right, so pretty much last before we dive into some stuff, what cases do you think we're concerned with? So, for instance, in our example problem here, I could have the case where my array is empty. Am I concerned with that case when I'm talking about how efficient my algorithm is? You have to think about what kind of case we'd be concerned with. Empty case, nah, it's too easy. Worst case scenario. We want to know worst case scenario. Regardless of what algorithm we're working on, we want to think 10x, a la Google, Facebook, all them giants who have immense amounts of data. Say we had all the data they had. Are our servers going to crash? That's the question we want to ask. as we get more and more data, I didn't mean that to be all caps, but it's just gonna be all caps now. As we get more and more data, how does our algorithm perform? We're gonna look at the worst case scenario. At times, folks will also ask you about like the average case. If they do that in interviews, don't get intimidated, but typically be like, what's Big O? Now, like, what's the average case probably? Some folks do like to just like see how you handle pressure. Not really a trivial, just to see how you respond. I'm one of those sometimes. Again, don't freak out. Just like have a conversation. Okie doke. So now we get into types of Big O to cover. Actually, before we do that, I'm gonna do one thing, just to show you guys something. So, console.log, we're checking two numbers here. So I'm gonna put a console log inside of this double for loop. So every time we're checking two numbers, we can see. So the first time through, I got 49. Second time through, I got 16. I didn't get anything. And then the last time through, I got 16. Cool, 49, 16, 16. And test array, for good measure, looks like this. Bam. Why 49 and 16? Why did I run that number of times? No. No. Yes, you haven't talked about many times. Go.
Factorial?
Yes. Or no, squared.
Yeah.
Squared. Quadratic. Yeah, quadratic. So we end up seeing when our array was length of 7, we see that console log, that's tiny, no one told me. We end up seeing that console log 49 times. We see n, the length of the array, times n. Por qué? Because this one loop runs n times. The second loop also runs n times. Each of this thing that runs n times, that's also known as linear in Big O notation. Effectively, what linear means is that the number of computation grows linearly in relation to the amount of data you have. So if you have a million things, worst case scenario, it'll run a million times. Now, notice how these are nested? This gets into then how do you add up this whole function and all the behavior inside of it? How do you add up and get its whole Big O notation? When things are nested inside of each other, you're gonna multiply them. When they are siblings to each other, you can add. So for instance, going through the rest of this, let's go line by line. Line 26, do we think this is linear? Does it matter how much data we have? Just setting up our answers array, it does not matter how much data we have. That's also known as O of 1 or constant time. Constant time means don't matter how much data you have, it's going to be the same amount of time every single time. Irrelevant. Oh wait, constant time. Did I say linear? Might be, guys. These two are linear. Okay, line 31. Constant or linear? Those are the two that we know so far. I heard a whisper. If you whisper, it'd be great. Say it louder. Say constant? Yes. This guy is also going to be constant. Because no matter how big our array is, in this single computation, I am accessing a number, and doing a comparison. Regardless of whether there are 20 things in my array or 100, This isn't gonna take any additional computations here. Does not matter. All right, how about this push? So now I'm accessing a number, and I'm pushing it inside of my answers array. Constant? Yeah. This, I believe, is constant. The thing that I'll give you now is kind of a hint for something in a moment, is any of these array methods, push, map, includes, index of, there are things going on under the hood there that you've got to be aware of. So if the way that push works actually is linear, you want to know that. So if in an interview you're going through your code and figuring out the big O, you're like, that's just constant. Interviewer will be like, is it really? And hopefully we'll actually give you that hint versus just being like, oh, they don't know their stuff. Or like, it went over their head for a second. This one, I believe, is in fact constant time. So if we add this up together, we get, so I've got, let's see, that's n squared, there to multiply, and then maybe like plus 1, because I got this 1 out here, and all this is happening inside. Question, shoot.
Is answers.push, is that always constant also because of the fact that it's just pushing 2 values inside of an empty array that is constant?
Even if the array is not empty, like the second or third time through, it'll still be constant. Is there an example or a what if you could give me for like, would it be constant still if with push? It's okay if you can't. All right, let's revisit it, and also just we will revisit in general different array methods. So you'll see some different examples there. And so as I add this up, I might be able to do something like big O notation of n squared plus 3 because of all of these linear times. You don't need that. You're always going to simplify down to what is the largest piece of that equation. Now, why would we do that? For instance, say our array.length is equal to, I don't know how many zeros this is. Do you guys know that a Google is a 1 with, I think it's a million zeros behind it? Is that what it is? I'm looking at you like you would know, but I don't know why you would know. I only know because in 3rd grade, when we were being bad, I didn't know this till after, this is why she did it. My teacher told us the first person to write a Google would win some candy. I won, clearly. But it kept us busy for like 3 hours. All right, so say this is our array length. O plus 3 versus I should not have done this with a square. Oh, geez. This won't be entirely accurate, friends. I'm just going to add some more 0. Okay, so we're going to say that was what I was working with in terms of the length. So this one is going to be equal to however many zeros after that. Oh no, my computer is dying. Thank you, love. So if we do O of n squared plus 3, we're going to end up with 1 bazillion 3 versus 1 bazillion. Want to know what doesn't matter in that case? 3. It doesn't matter. You are glorious. So we simplify down. In a moment, I'm going to show you some other cases. And regardless, you always look for the worst case scenario. Okay. So things we've talked about so far. So many of these. We've talked about constant time. Colloquially, don't matter how much data. Linear time, As the data grows, the computations grow linearly. Quadratic, as the data grows, the computations grow quadratically. All right, I want to show you guys a visual of this. Some colors. Be helpful for like, what do we like and what don't we like? So, notice how little green there is. Green is excellent, yellow is good, orange is darker yellow is fair, orange bad, red horrible. There's an example of this in the review I'll send to you guys. The only things in green are constant time, O of 1, and O of log n. We'll get into log n in a second. It's one of my favorites because binary search trees are glorious. Even constant time is not awesome. There are some of these in here, like n log n, that honestly it's a little bit difficult to come up with a substantive example for you guys, and I'll let you explore on your own. The minute you get to quadratic, and then, what is that? Exponential, and then factorial, you go from having like a data set length of 1 to 10, and it's skyrockets. 100, 1,000 might break your computer. It's a lot. So we need to stay away from these guys as often as humanly possible. Okay. So, before we dive into actually optimizing our code, I want to dig in a little bit more to just reading some code and figuring out what is the O notation. And this is where secrets below. Do not proceed. It's okay. You can enter. Okay. So what I want you guys to do is with the folks at your table, I don't think anybody is solo. We have some threes, we have some pairs, is I want you to look at contains average, first line by line. What's the big O of each line? And then to decide for me to come up with a guess, what's the big O notation of contains average overall? Do we think 4 minutes is solid to do this? Okay, I'm gonna start this 4-minute timer and then put the code back on the screen.
And then I guess the target what is
Although it's just
I don't work out enough anymore. You were like,
I think it's
Like that line?
Right, so right
Like step 106.
Right now they're all, no, they usually constant, but okay, it really depends on when it comes to runtime. The runtime. Yeah.
5, 4, 3, 2, 1. Yes, it's time. Okay.
Yeah.
The way that I like to do this is by a show of hands. We're gonna go line by line. I put these down here so that once we have a decision, we can pop it back up here.
Are we talking about the actual runtime?
We're talking about the number of computations, not seconds. We are not seconds, milliseconds.
So that
Yeah,
means.
it's like
All right, I'm gonna do another 5, 4, 3, 2, 1. All right, line 107. By show of hands, do we think that it is linear? Got one? One. Constant? Got a lot of people who are just not confident yet. 2, 4, 7. I see. And a whole bunch of non-votes? Quadratic? 2? I'm not mad. All right, so I'm the slightly not nice instructor that immediately the first line has you use a different method. So realistically in this one, we're just setting a variable to the call to this method. So we've actually got to look up here at what this guy does. Now, this guy takes an array and returns array.reduce, yada, yada, yada. So we've got to know what reduce is doing and what its big O notation is. It ends up being linear time because of the behavior. So I believe, unless they change the behavior for it. So this ends up being linear time, line 107 does. A lot of different array methods are linear time. In our code, they might look like, okay, that's just constant, but under the hood, they're doing the way that we would do it in vanilla.js for the most part. Like mapping over, it does a for. It goes over every single one, so it's linear. Bam, line number 1, done. Okay. Line number 108, by show of hands. I'm gonna move constant up, that's confusing for me. All right, constant time. 2, 4, 6, hands going up slowly, 7, 8, guys! All right, I'm going for 8. All right, linear time, by show of hands. See, 3. Quadratic time, by show of hands. 1, because why not? All right, in this case, the most votes actually do win out. Dot length, I appreciate the instinct here of but what on an array is constant versus linear? So dot length, constant. I'm gonna mix up these words at some point. I apologize in advance. Dot length, constant time. Mathematical operations like division, constant time. It doesn't matter how big the data you're working with is. So this ends up being chabam, constant time. All right, and then 109. So 109, by show of hands, constant time. Da-na-na-na, da-na. Yeah, I swear a couple of y'all are just like putting up a hand, just put up a hand to have some votes. They can get 0. It is okay. All right, linear time by show of hands. 2, 4, 6, 8. Who do we appreciate? Okay. Quadratic time. Yo, so many of y'all are not voting. We went from like 15 votes to 7. Don't understand, but it's okay. This is also linear time. So that index of average is what makes this linear. If you were gonna write index of under the hood, probably use a for loop. You couldn't use any of the array things. You loop over and see, does that thing exist? If it does, return the index, otherwise return -1. They're doing it effectively the same way. If your behavior would be linear, so is that. The reason I'm talking you through that versus just being like, just know it, is because if at some point you're using one of these, you're like, crap, I don't know. You can think through it logically, and if you think it out loud, even if you're wrong, they're gonna respect your process. Okay, so then, what does this make contains average? But before we answer, shoot.
Oh, I was wondering, should we know this just like automatically, like in a rate?
Definitely not right now, because you just started. So at the end of this, I have a whole bunch of resources and one that I forgot to put on, like LeetCode, HackerRank, Code Wars, for you to get more practice doing algorithms. Those things often don't prompt you to do the Big O yourself. I'm gonna tell you to start doing the Big O yourself, just to practice it, and to practice it together. This is gonna end with me being like, I really appreciated this. Here's how I think you guys should go forward. We're not going to but yes, all that. I heard it. I keep swearing I hear like whispers of like, what? And it's really weird. It's fine, the room is haunted. All right, so what does this make contains average overall? Oh, of what? Have any? So I see you already removed the +1. Yeah? But I like that. So we simplify down there, like we talked about earlier, where we had the n squared +1 or +3. You can automatically take that one off. You can actually simplify down to n as well. In the scheme of things, when n is infinitely greater, multiplying it by 2 is negligible. The difference between 1 Google and 2 Google, a Google is still giant. So you don't need the 2. We keep it simplified to the exact same notation that you would see on this chart. So if it was like 2n factorial, n factorial, we're done. You don't need the 2 on there. Yay! Guys, you learned so much already. Okay, so I'm gonna check my README because I totally might have skipped something. Oh, I did, okay. Last couple relatively quick thoughts before we go into actually improving our code that we started with. So one thing is that I'm gonna move this guy up here. So logarithmic time. How many of you guys are familiar with binary search trees? Didn't really expect you to be. They're my favorite though. So there's a lot of different versions of them. They make things a lot more effective to search through. A lot. I'm actually gonna backtrack momentarily. So say you were searching for an integer in an array, and the array is unsorted. What is your worst case scenario? So I've got an array of 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 50, but I'm searching for 60. What's my worst case scenario? Or it's not there at all, and I have to search the entire thing. If that array is sorted, however, my time gets cut in half. Because if I have 1 through 50 and I'm searching, or I know it goes between 1 and 50, and I'm searching for 7, I don't know if it's there, I start in the middle. If the middle is too low, I move right. If it's too high, I move left. Binary search trees are essentially another way to represent that. So, say I'm looking at this tree right here, which I wish would be bigger. Open image new tab, solutions. Okay, say I'm searching through this tree right here. The rules of a binary search tree are essentially from any given node, there's one root. You can have up to 2 children. The left child has to be less than its parent, and the right child has to be greater than, or beside that, so on and so forth. This guy is balanced, meaning that as many children are on the left or on the right the whole way down. You can have wildly unbalanced trees, like say 42 is the root, it would just go straight down to the left. That would be terrible, because you would still have to search all the way down. But say I'm looking for 15. I start at 27, 15 is less than, I go to 14. That's not my number. My number is greater than that. I go to 19. That's not my number. My number is less than that, but this one has no children. That only took me 2 computations. Versus if this was an array of these numbers, there's 7 of them, it could have taken me 7 computations. This is logarithmic time. Log n. Which basically means every single computation that you do splits the amount of data you're looking at in half. It's really, really nice. I will add some additional resources for trees. We don't have time for today, but they're so much fun. There's red-black trees, there's AB trees, there's so many different ways people have made this stuff. It's so much fun. Okay. And then our absolute worst case scenarios. Exponential and factorial. Recursive Fibonacci, I'm not going to go into so much. One of the resources I have does go into this for you. But do you guys know about the traveling salesman problem? I love this problem too. Because there's like, as far as I know, not a nice way to solve it yet, but it's like a fun problem. Short version, there's a salesman. He has to make 50 deliveries across the continental United States. How does he do that and take the least distance possible? He has 50 steps all across the country. In what order does he go to make it the quickest possible? Figuring that out is factorial. It would take you forever. You go from having 1 stop, cool, that's fine, to 5, that's already a lot of options, to 100, your computer might stop now. Restart and just keep it moving and figure out another problem to work on, because it's a lot. Okay, we actually already did this guy, which I'm really excited about. And now we can get into actually improving our code. I'll leave these here for now. Okay, I would like to give you guys another 4 minutes to see if you can come up with some options of how to make this more efficient. There's one hint that I will give you that honestly I'm not sure that will connect until we discuss after, but I want to see how it works. Which is that things like looping through arrays and index of are linear time. Finding an item in an object, however, is constant time. Meaning, that is O of n versus is constant time. So if I have to tell if something exists, I really like objects for collecting. This is our base code. I'm gonna give you guys 4 minutes in those same groups. Just come up with some ideas of how we can make this more efficient. Before we do that, question?
I have a question for the code that we wrote down. Say for whatever reason we need like an extra for loop in algorithm.
Cubic.
Cubic.
Yeah. as you go deeper, it just keeps multiplying. So then it would become n to the 3. All right, y'all ready for this? 4 minutes begins now.
To make less complication, to come up with a solution that make it less complication.
Right now, that's the best case it's amazing question. So can you figure out how it's starting to not necessarily solved, but
Right, so this is where you
I got my answer.
You'll be fine.
You got your answer? What is it?
I know that my code is very
Yeah, so
the best way to run time.
You're doing 2 for each?
I'm not sure exactly.
so just this
I could also for each first thing chapters off. You don't have to get there. You don't have I never started it, so we're gonna do this.
We can do it with equation.
Yeah, so like, I think like this.
But if you have some
I just have to do the arrow down here because I can get right there for each
You got about 15 seconds left to get through what strategies and stuff that you want to track. I want your brains to hurt. That sounds really mean. All right, let's bring it back together. So, show of hands, how many of you guys are like my brain slightly hurts and are like a little bit frustrated? No?
Yeah.
That is a-okay. I will say that, like, I hope you guys start to generally kind of enjoy that, like getting to the other side at least, because like, this is also the fun stuff of building, at least in my humblest of opinion. Like, you know how to build a Rails back and like building that is cool, like building the front end is cool and satisfying, especially if you're into like designing really cool stuff. But at least for me, the really fun moments are when it's like, I've got to achieve this thing I've never achieved before. Like, I've got to think through how to make it happen, like, relatively efficiently, and like, solve that problem, how to structure it. And I was like, spin up a new component, I can do that. This is where the fun is. It also is where some of the headache is. But if you can find it fun, it's going to be a really enjoyable career. Okay, so ideas. We're not going to code them out, but what ideas did folks have about how to improve this? And I'm going to show you the most optimal one.
I thought about using the .find method.
There was one thing that you did in addition to that I really liked. It looked like you did something like let like complement equal target minus array first. That you were like, let me identify what the number I need is. Is that something that you did? I really like that you did that. You like put that someplace, so it's just like, I can just check, is that number somewhere? And then so your instinct was just to be like, so array.find complement. Is it in there? Now, the issue with that one is find method, also linear. So we still end up quadratic. Inside of first loop. Any other ideas that people had? Even if you were like, nah, that actually ain't gonna work though, because we can learn from that. You look like you're gonna say something. Wow, I'm gonna look at you.
I don't know, just be faster, but I was thinking maybe we could split it and then check, like sort and then split and then just check from the right array, the array on the right, and then against the array on the right.
Yeah. I feel like I heard a couple other people talk about sorting the array potentially. I like the instinct. Sorting in and of itself has some big O implications, so it's not going to be the way we end up going because initially it's a heavy lift. After that, then you get to that log n, but you still have that heavy lift initially. I like the instinct. Any other things folks want to throw out? Shoot.
I'm not really sure exactly how to do it, but I guess if you can convert an array into an object with the value, then you see complement like to see if that complement is inside the object, and it will be a constant big O.
Yes, I like that instinct there. So thinking about using an object to figure out if the complement exists instead of having to do this second loop. And this is where we're gonna start to get fancy. But what I'm gonna do is, I'm gonna make us a second version. It's gonna be called non-optimal now. Versus just has target sum. And do some cleaning. So instead of doing the work from jump to convert the whole array into an object, I'm gonna do something from the top. Namely, I'm gonna say, let scene numbers equal an array. I'm gonna collect everything that I've already seen. Just because then I know it's there. And then, whenever I'm looking at any individual number, I can say, hey, have I already seen this complement? And that's the case at which I want to answer.push array first and complement. Then, at that point, regardless of whether I found this complement or not, I need to add my current number into my C numbers, so the next pass through, I have access to it. And then I'm going to return my answers. This is a technique called hashing. And it's going to be one of the first ones that you're going to use when you're working on an algorithm. And they're like, optimize. Like, this is genuinely the first place that I would tell you to think through, like, could hashing help me? Could creating an object to collect what I've already seen make it easier for me to then look up later on constant time, because this check here is constant time. And therefore, reduce the number of computations my whole function has. So this guy is linear. This is constant. So is this. So is this. So is this. We only ever have O of n now. Shoot.
So what you said is like making a cache specific for a function?
Essentially, yeah. So like key terms, which are in your README, that when you're working on these things, I want you to explore hashing and memoization. Two really big ones. There's a lot of other stuff to explore in the way of like algorithms and efficiency, just things to know in the current coding world. I would point you first to those two. All right, I feel like it would be helpful, however, but if this would not be helpful to you guys, shoot, to actually see in each pass through, what's first, or what's the number we're looking at, what's the complement it's looking for, and what's currently in that object that we're hashing. Folks want to see that, or is that like, our brains are fried, it's lunchtime? Let's see it? Because I'm going to push this code and y'all can do it yourselves.
Still need to declare answers at the top.
Say again?
I think one needs to still declare answers.
I do, thank you. Ah, yes. Save me from myself. First number. Array first. Complement. Scene numbers, scene numbers. Okay, we're not gonna have it go through all of these, because that would be a lot. Okay. You know what, actually, first, cause log array and target. Bam. Okay, so we've got our array of -1, 3, 8, 12, 14, 17, 11, target is 10. Iterating through, first number, -1, looks for the complement 11. We've added -1 in, 11 isn't there. It just continues. First number is 3, complement 7, adds 3 in, 7's not, whoa. So one thing about the browser, it'll print to you what it looked like at the time, but if you expand it, it'll show you what it looks like at the end. Don't get tricked by that. All right, first number 8, complement true, adds 8, but 2 isn't in there. First number 12, complement -2, not in there. 4, 6, not in there. First number 11, complement is -1. -1 was already in there. We've added something to our answers. And it then goes and adds 11 in. First number 7, the complement is 3. 3 was already in there. Now we've got an array with just 2 answers at the end. We no longer have that duplication because we're no longer double looping. So, I always do this too. At the end of this, would I expect you guys to have like, all right, like trial by fire, we're gonna all do like one right now. Would I expect you to do this optimization confidently? Yet? No. But what I want you to walk away from this is with a couple of things. is with this approach. That first like half of this that we did, that was just talking through, is really what's gonna make you stand out in an interview. If you can code it and optimize it, but you're silent the whole time and look grumpy and don't talk to nobody, you're probably still not getting hired. You're probably not. So making sure that you are talking through. Seriously, your own words, actually pseudocode. And then one thing that I have in here that I didn't show you guys, don't stop talking. Like literally, do not stop talking. If you're struggling, no one can help you if you're silent. Most interviewers are not going to interject if you are like, do not seem amenable to having conversation, period. So that's the first thing. Take away this approach. Secondly, is I really just want you guys to be more comfortable exploring Big O notation and how to calculate it. You don't always have to be right, it's a skill. You gotta get good at it. But what's constant time, what's logarithmic, what's linear, which is better than which, and having those terms. So you can talk this up. You can walk the walk, you might actually still be crawling, that's okay. Fumble, that's cool. But be able to talk some of the talk. And then, lastly, is to practice the heck out of this. You don't necessarily need to do it right now. I know you got projects and modifiers coming up for some of y'all, and that's a lot. But what I would advise is on a daily basis, set aside 10 minutes. Right before lunch, right after lunch, before the end of the day, right in the morning, whatever it works for you. Pick one of these guys. My favorites would probably be Code Wars, to be honest. But do an algebra problem every day. Think about the Big O notation, and then at least once a week, get together with somebody. Have one of you guys be the interviewer and one of you guys be the interviewee, and practice this. Because realistically, you can be as good at solving algos on your computer as you want to be, but if you haven't practiced doing it in front of a person, that anxiety can get the best of you in an interview. That is also a skill, interviewing very much. Career Services will rant to you about this, but I'm sorry, now. The more you get comfortable doing this with folks that you're comfortable with, when you're in a room with somebody that you don't know, that you're like, this person has power. They have decision making over my employment. I'm not employed, they need a job. That is gonna be a part of that dynamic. But if you are so comfortable doing this already, it's gonna take a lot to blow it off. So practice this. This is also a skill. I think with that, I'm gonna get off of my soapbox, and thank you guys for being such active participants. Have a good lunch.